Hello, welcome to the second ICCAP tutorial. In this video, I will show you how to use your model or model library in ICCAP. I have prepared two examples. One is for core model, the other one is for model library. We will take a look at those together. Now let's take a look at the first example. I only have a test device here, and let's take a look at the circuit part. I just put netlist of the model directly in this circuit part, and then you use this button to pass the parameters to the model parameters. Then all the parameters can be tuned in the later model extraction process. Let's go to the duty and setup. We have only one test duty and test setup here. There are some parameters specific for each device geometry, and then the setup level, it includes all the measurement data and the simulation value. Then we can go to the plots and open the IDVG curve, and then open the optimizer and select the parameters we need to tune. We can search and add parameters to the table, H0, U0, After adding those parameters, we can open the tuner to manually tune the model or use the optimizer to optimize it. And then the second example, we include the model library directly for the simulation part. Because in some cases, for example, for the RF model case, we have finished the baseband model part. We'll need to add a subcircuit to the baseband model and then tune the parameters of the subcircuit part. We use this very simple example to explain this case. So you can see I have included the model card here. Suppose this is the baseband model, and add a subcircuit, give it a new name, and then for different device geometries, the instances are different. We need to specify the width, length, finger number for each device geometry. That means for different DOT here. And we use this $dpar to make it DOT parameter here. That means these instance parameters can be changed for each DOT later. We'll call the core model name from this model library. The parameter in the subcircuit we want to tune, we can add it here. And for example, I only add one CGD parameter for the RF subcircuit part here. And also we made it a dpar because we need to tune it for each DOT. And at the end, we can create an equation for each DOT to combine those parameters. In addition to dpar, there's also MPAR, SPAR, can be used for the model level and the setup level as well. Another new thing we used is the echo. This echo allows us to send the content behind this sound directly to the simulator. That means even this line, the syntax is not right. When you click this pause button, there will be no error shown here, and you will pass directly to the simulator. And also, there will be no model parameters passed to this table. All the model and the subcircuit goes directly to the simulator. And then let's take a look at DOT part. I have only one duty here with the geometry 10 by 10 with one finger, and the curve measured for this device include the IDVD, IDVG for the baseband verification part, and also the open shot structure and the actual device. And in this case, I only added a CGD in the subcircuit part. That's the thing we want to tune today. We can take a look at the DOT level, no test circuit, and the DOT parameters. There are 4 parameters here. They're from the parameters in the circuit part, we add dpar. In this CV part, this data is calculated from the DOT and open shot. This CGD is the parameter we want to tune here. We can add an optimization step and then open the plot and then open the tuner to tune this parameter. Okay, these are the 2 examples of how to use a model card or model library to tune your model in ICCAP. Thanks for watching.